Have you ever wondered what makes fireworks explode in color? Or why soap removes dirt? Or why a piece of iron rusts? Chemistry explains it all. In the next few minutes, we are diving into the science that connects everything around you, from the air you breathe to the stars in the sky. Let's unravel how this science shapes our world. Welcome back. I am Rock, your bio and chem tutor. Let's simplify today's topic. In this video, you will get an overview of what chemistry is all about, its 5 main branches, and how it connects to real-world applications. What is chemistry? Right on the board, chemistry is the study of matter. Chemistry is the study of matter. Its structure, composition, properties, and the changes that matter undergoes. In simple terms, chemistry is the study of what substances are made of, how they behave, and how they change. So if we say that chemistry is the study of matter, what is matter? Matter is anything that has mass and takes up what? Space. The physical things that we can see, we can touch, we can feel. It includes from everything from the smallest atoms and molecules to large macroscopic objects. Everything around you, from the air that you are breathing to the food you are eating, your toothbrush, the water you are drinking, the pen, okay, the marker, all are what? Made up of what? They are all matter. And matter are made up of tiny particles that we call atoms. Atoms will be treated in another separate video. So what do we mean by structure? Breaking this down. Structure simply means how things are arranged, or how they are shaped, or how they are organized within a particular substance, and also the forces that holds them together. This is talking about structure. So everything, the matter, we're looking at how these things is what? Organized. Then composition. What do you mean by composition? Chemistry investigates what matter is made of. If you have a pen, you have a phone, you have a glass bottle, or any substance around you, a chemist studies to know what type of materials can be found in them. That's composition. For example, glass bottle. The glass bottle is made of primarily of sand. And you know sand is what? Sand, yeah. Sand is made up of what? Silicon what? Oxide. And then we have limestone. What's limestone? Calcium what? Carbonate. And then sodium what? Carbonate. As Na2, CO3. We will come to all this in other videos, how to name chemical compounds. Okay, so soap is made from what? Fat and oil. That's the composition. So a chemist studies to know what matter is composed of. Then we come to properties. Chemistry examines the characteristics of what? Matter, such as we have physical properties and what? Chemical properties. So the physical properties talks about what? The color. The yellowish color of sulfur powder, the purple color of potassium permanganate, the greenish color of chlorine gas. Also talk about boiling point. Okay, water boils at 100 degrees Celsius, ethanol boils at 78 degrees Celsius. You talk about solubility. All of these are physical properties. And you talk about chemical properties, it has to do with what? Reactivity. A new substance is always formed in that area. Okay, so all of these are what we look at when we study what? Chemistry, the properties of what? Matter, structure, composition, and what? Properties. And also the changes that matter undergoes. Chemistry focuses on how the structure of matter changes when substances are reacted together in any chemical reaction. Chemistry focuses on that. This reaction that is taking place is actually the rearrangement of these atoms. Let me not even go into that topic. It's a different subject, it's a different topic on its own. The rearrangement of these atoms is where we produce a new substance. For example, if hydrogen, a gas, react with oxygen, a gas, water is produced. Don't worry, I have a lot of topic where I'm going to explain how equations are what? Balanced. How chemical equations are what? Balanced. Okay, because on this reactant side, you have 4 atoms of hydrogen, and then on the product side, you also have 4 atoms of hydrogen. And oxygen, you have 2 atoms of oxygen, and then 2 atoms of oxygen. So this equation is a balance. It's a topic for another day. So if hydrogen, which is a gas, react with what? Oxygen, which is a gas, then we produce what? Water. These are the changes that matter what? Undergo. When sodium, which is a metal, react with chlorine. Sodium, which is a metal, react with chlorine. What is sodium? react with what? Chlorine. Now, sodium is dangerous if you take in sodium, okay, is a metal. And then chlorine gas, chlorine is very, very poisonous, okay, it's dangerous. But when you combine these atoms together and then you produce a sodium chloride, that's table salt, what you add to your food. Understanding these changes allows scientists to manipulate matter for various purposes, such as creating what? New materials. Chemistry is often called the central science because it connects with many other disciplines. Chemistry is the central pillar of scientific understanding. It is a giant hub of science knowledge. Very, very important. So we want to look at the branches of chemistry. Now, the study of modern chemistry today has many branches, but it can generally be broken down into 5 main branches. Branches of chemistry. One on the list, I have analytical chemistry. I have organic chemistry. Number 3, inorganic chemistry. 4, physical chemistry. And number 5, biochemistry. So we have 5 main branches of chemistry. So number 1 is analytical chemistry. Analytical chemistry is a branch of chemistry that focuses on identifying substances and determining their amount. That's analytical chemistry. You want to go into a career in chemistry to become an analytical chemist is very, very important. So it involves the use of various techniques and instruments to separate, identify, and then quantify the component of a sample. So it plays key role in various fields. For example, in quality control, analytical chemistry is used to test the purity and then the composition of the product, such as your food, your pharmaceuticals, and cosmetics. Okay, then in environmental monitoring, analytical chemistry plays a crucial role because it's used to monitor the levels of pollutants in the air, in the water. You take a water sample, soil sample, and you monitor the level of pollutants that you have in this environment. Then in forensic science too, analytical chemistry is used to analyze the evidence in criminal investigation, such as your DNA analysis. So organic chemistry, when we hear the word organic, what comes to our mind? Organic chemistry is a branch of chemistry that deals with the study of carbon-containing compounds, their structure, their properties, and their reaction. Carbon is one of the most abundant elements on Earth and is capable of forming a tremendously vast number of chemicals. Organic chemistry plays a crucial role in various fields. In pharmaceuticals, organic chemistry is used to design and synthesize new drugs, antibiotics and anti-cancer agents. Your plastics, your fuels, your carbon-containing compounds. Fibers, plastics, fertilizers, and pesticides, all of these fall under organic chemistry. We go to the next one, which is inorganic chemistry. Inorganic chemistry is a branch of chemistry that deals with the study of inorganic compounds. That is also their structural properties and the reactions. That is fall under inorganic chemistry. What do we mean by inorganic compounds? Inorganic compounds are compounds that do not, in general, they don't contain carbon at all. They are commonly found in rocks and minerals. Inorganic chemistry also has a crucial role it plays in various fields. Today, I have what we call the dental implant. Glass and ceramics that are used in dental implant is being synthesized today. This fall under inorganic chemistry. You have metals and non-metals. You have acids. New battery technology today is also being produced from our lithium-ion batteries. Is under inorganic chemistry. Then number 4 is physical chemistry. Physical chemistry is a branch of chemistry that deals with the study of the physical principles that is underlying chemical reactions. What makes matter behave the way they are behaving? They have to follow the laws. So this one combines chemistry with physics to understand the properties of matters and their behavior. So physical chemistry tells us about how energy changes that occur during chemical reaction. That's under thermodynamics. Physical chemistry is also used to understand the rate of chemical reaction. So reaction rates fall under physical chemistry. The laws of physics has to be obeyed. So we use physical chemistry to understand the behavior of molecules at atomic level. Then we come to the last one, which is biochemistry. Biochemistry is a branch of chemistry that deals with the study of chemical processes that occur within living organisms, whether plants or animals or microorganisms. Within living organisms, chemical processes that are taking place there is being studied under biochemistry, the study of biological chemicals of life. So it also plays its roles in various fields. In medicine, biochemistry is used to understand the molecular basis of what? Diseases. Cancer and diabetes and all these are being what? Studied in biochemistry. I studied biochemistry and microbiology. So biochemistry has to do with what? The study of what? Chemical processes that are taking place in a living organism. These are the branches of what? Chemistry. The 5 main branches of chemistry. Each branch of chemistry plays a distinct role, but they often what? Overlaps with the other in order to solve complex scientific problems. So there's an overlap. It's not easy to separate one branch of chemistry from the other. So you've learned what chemistry is. That's the meaning of chemistry, the 5 main branches of chemistry, and how they connect to real-world applications. If you found this lesson helpful, don't forget to like, share to your friends, and also subscribe. Keep learning. In our next video in chemistry, we will be looking at atoms, molecules, and ions. Make sure you subscribe. Thank you.